Hello, my name is Brian Fetz. I'm the product manager for USB for Keysight Technologies, and we're going to take a look at some of the solutions we have for USB 3.1. So specifically, we're going to deal with cable test with the vector network analyzer. We'll deal with transmitter test with the oscilloscope, and then we will deal with receiver test using the Jaybird. So this is the display for the E5071C ENA option TDR. On the left-hand side, you'll see the TDR or the time domain data, and on the right-hand side, you'll see the frequency data. The ENA takes its data in the frequency domain, which improves the signal-noise ratio and can actually then manifest signals that or waveforms that look like time domain waveforms, but actually time domain waveforms. The benefit to this technology is that we can actually measure not only accurately with high signal-noise ratio on cables and such, but we can actually measure the active transmitters. In addition, this network analyzer can render an eye mask or an eye diagram given the data it takes in the frequency domain. This is the display for the real-time oscilloscope. In this particular case, we have a 33 gigahertz oscilloscope. For the 3.1 USB, we need at least 16 gigahertz of bandwidth. You'll see that we have a software package on top of the display, and that software package is showing SIG-Test, which is a Intel software to analyze jitter and eye diagrams, and is required for compliance for USB. So this is the display for the M8000 Jaybird. This is where we want to test for receiver sensitivity of a design. And in particular, it must meet the mask as shown on the right-hand side here. It must be above those two lines. And what the Jaybird can do is create what we call a jitter cocktail, which is composed of intersymbol interference, random jitter, and periodic jitter to stress a receiver. And this is a portrayal of a passing unit on the right-hand side. So that's a quick tour of the USB 3.1 solutions. Thanks for watching.